Hi, so I decided to make this video to go as a bit of an appendix to the instructions. Here hopefully you'll see exactly how the robot goes together and get a rough idea how long it will take your participants to complete the build. I'd recommend by asking all of your participants to neatly arrange all their stuff. So I like to throw all the small stuff kind of over to one side, and then just the big stuff to the side. So the instructions start off with identifying this piece here. This is what I'm calling a side piece. So as you can see that they're labeled left and right. So your right side piece, you want the bolts going through this way. For your gears, but you want one bolt to go in the opposite direction. This is where you're going to mount your sensors. Now, as part of the kit, you have one of these spanners. For tightening things reasonably tight, I'd recommend using the close end, and for just maneuvering things, I'd recommend using the open end. So I'm trying to tighten this up as much as possible, as reasonably possible, because if this comes undone, the gears won't align correctly. So for these bolts you can tighten them up again reasonably nicely. For the sensor, it's a little bit tight because you might want to move this to find your perfect sensor height from the ground. But the idea for your participants is that the height of this is meant to be thought-provoking. So you kind of want them to think for themselves, how high should it be off the ground? So that's one of my sides complete. Now the left side. You might be wondering why on these pieces that there's two of these slots. It goes back to the idea of it being thought-provoking, and it kind of gives them the opportunity, if they were to bring the robot home, to explore what happens if they mount the sensors closer to the robot. In other words, what does it look like if it's mounted here versus here? If it's closer to the wheel, is it going to make the robot turn worse or better? That's for them to find out. So now I'm on to mounting the rear piece, which, as you can see, it just kind of slots into here and then slides down. And we're going to do the same for the front piece, where we're going to put it in, slot it in, and slide it down. We're then going to get the right side piece, and putting it into these little slots, and there we go. You can see it's kind of coming together. And now we're looking at this small little piece here. On the file, it will engrave text. It is quite small, hard to see, but it says retainer, so this is what's going to stop the chassis from basically doing this. So putting these in is actually quite satisfying. There is like a little small tiny tab on top of them, and that will make a nice click noise. Okay, so that's done. And now we're going to mount the motors. So you'll notice that one side is higher than the other. The motors mount by the cable side going towards the curved part here. So they kind of slide in. You aim the shaft of the motor into there, and they kind of sit snugly in that little recess for them. And it's going to be the same for the second motor. So again, find where the motor is curved. Now if the wires are pointing the wrong way, all you have to do is curl them up like that. Point the motor in and slide it down and around. And it should fit snug, like so. Okay. So next thing we're going to do is mount these IR sensors. So the first thing you want to do is thread one nut on. This is going to be for setting the position of the sensors themselves. And this is yet again another thing that I'd really want like my participants to think about, is varying the width. How close to the middle should the sensors be, or even how far they should be from the center, because that will affect the performance of the robot. Now I did run a workshop with a few adults and asked them to assemble the robot, and they found it difficult to try to mount this, but it is just set the position of the first nut, pull the sensor in along it, put your second nut on, and then tighten it with the open end of the spanner. And the open end of the spanner won't let you, almost by the nature of it, won't let you over tighten it. It will slip on the nut before it does that. And then the second sensor. Now the accuracy here isn't the world of importance, like the robot will correct itself regardless, but like as you can see there, I would call that like good enough. So second nut on. And tighten that up. You want to tighten them to the point that they're just not spinning around anymore. So I'd call that good. So I'm going to try to move the wires down to roughly where they're supposed to go. So down that way and this way. Just make sure that's nice and tight. Perfect. Right, So now we're moving on to these guys. So in the kit, you can see that there's these tiny dowels. They are very small, but they do fit quite well into this gear here. I'm calling this G3 because it's the third gear in the drivetrain, and it has these little holes for your dowels. So how I put the dowels in, one of the sides is sharper than the other. I start off with putting that into small gear, and I almost push it all the way through. Same again. And this is a press fit piece, meaning like it is supposed to be snug and tight in there. And there you go. So that's one. That can now slide onto here. I'm gonna leave him there for a second and do the same for the other side. So where I'm mounting these gears is on this bolt here. So moving around to the other side. This gear should be pointing out towards this way. And you can see already we have a nice engagement between the two gears there. Now, this is a part that might trip up some participants, so you might need to relay this to them. This part actually requires them to potentially borrow one of the spanners from another participant, but it's not essential, it just might help. So I'm going to get these reasonably close, so I have about that much space, a little bit more, about that much space in between the gear and the two nuts. And I'm going to hold one of the nuts and I'm going to tighten it. And now that should hold down there without spinning, as you can see. I'll do the same for the other side. There we go. Okay, now we're going to be installing the big gear, but there's an order in which we do this. In the kit, there are these parts here. What some participants might do if the robot ends up having errors is it's because this spacer is on backwards. There's a small little recess on this spacer, and that's to allow the user to tighten up this pack without interfering with how well our G4 spins, our biggest gear spins. So I'm going to put them in that order. The order is, the best way of putting it is this face should always be towards the gear. So showing you that again, that's your sleeve bearing, that's your gear going on, and this way goes on top of there, and then we just put our nut on. Now you don't want to over tighten this either, because you can compress it to the point that it will rub against the big gear. So let's say use your instinct. So if I over tighten it a little bit more there, we're still good. So I wouldn't say much more than that. Now the other side. So this one first, your sleeve bearing, and then your big gear. And you notice again, this side is flush, there's no recess. The recess is pointing towards the big gear. And now we just tighten this guy up. Over tighten it a bit. Just let it out ever so slightly. A little bit more. Perfect. Okay, now onto the electrical part of the build. I'm actually wrong. You need to put your battery pack in. Now, in the instructions I tell the participants to put their battery pack in first, and they might ask, why does it not have batteries in it? Well, it doesn't have batteries in it yet, just in case they make a mistake during the wiring and they don't go plugging it in, all for their robot to just fail. So I fed my wire up through the motors. It's not too difficult, but it doesn't necessarily have to go all the way up here. There are other paths for it to go, but this is, I think, the best way to put it in. And it slides up there, and to prevent the battery pack from falling out, we have this nice little clip. And this clip goes into the bottom part of the robot here and clicks in. Now the battery pack won't fall out. Now we're on to the electrical part of the build. So starting off, I'd ask your participants to acknowledge the orientation of the breadboard. So you want the letters to be facing upright. So when I grab my Arduino and I'm looking at it, I'm putting the top left corner into B1, and it fits in there. And for this piece here, this is your motor driver. You're going to make note of where this notch is. Not necessarily the circle, because where the circle is can vary from manufacturer to manufacturer. So we're looking at the notch. So that notch is facing away from the Arduino, and this is going into here. So the next step is to start your first row of power cables. Now forgive the blue cable here, I did run out of black cables. So that first red cable is going onto your positive rail here and into a 30. And this is going onto a 14 and onto your negative rail, like so. And your second round of power cables, you're going onto the positive power rail and into the 5-volt pin, or A11 on the breadboard. Excuse me, A12 on the breadboard. And your ground is going on this side of the board. Your next ground goes into J12, yes, J12 onto the negative rail on this side. And you want this going to J23 and onto the closest part of your positive rail on this side of the board. So now we're going to start with the motor control wires. So I'm looking at B29, so we're going into here. We're going to bring this wire all the way down to D7 on the Arduino, which on the breadboard is G6. And we're going to put the second one into, I can barely see it myself, H29, and this is going to D2 on the Arduino. And our next one is going to B24 on the breadboard, and D4. And our last yellow one, I believe on the diagram they're orange, but that's just so you can discriminate between them. So that went into G24. That goes into D3 on the breadboard, or the Arduino, rather. And now I'm using these blue wires. These are for our PWM signal. And on the breadboard, it's going into D23. We're jumping over to, just confirm that, D6, just to not get the mix up. And our next one goes from J30 on the breadboard to D5. So that's basically the wiring complete. It's not the prettiest version of it. I'm sure some of your participants or students will do a cleaner job than me, but there we are. So being sure of double-sided tape, I'm just going to slot my Arduino into, or my breadboard into here, but I'd recommend that you get some double-sided tape to stick on here. If not even, remove that small film that's holding that adhesive here on, and just put paper over it and then apply your double-sided tape, because if they peel this off and try to stick it onto here, you'll ruin the breadboard. There's little rows of your pins inside, and they will pull out with the adhesive if they try to remove it in the future. So the Arduino, or the breadboard again, does sit quite nice in there and is able to withstand a few rocks, but I think the double-sided tape does help, definitely does make a difference. So for your IR sensors, you can group the black wires and just put them into the negative terminals, negative rail on the breadboard, and your positive wire onto the positive rails. Now you need to determine which side is which for each wire. So your, let me make sense of this, your right side, your right side is going into A0, which is A4 on the breadboard, not to be confused with where the A is on the Arduino. So we're in A0 here, and our next one is going into A1, directly above that. And your motors your motors are going into so you may need to flip these wires if your participant is if their robot is spinning erratically or irregularly, and it's probably because these are swapped. So the negative one, which I have as purple here, it might be black for your kit if you put black wire on it, is going into D29, 28, excuse me, D28, and the next one is going into D25. Now over here, this one's going into G28, and this is going into G25. There we go. Yeah. The robot should be just about ready. This is the point where I'd ask them to make sure these wires are over to the side. You unclip your battery holder, put the batteries in, don't connect it to the breadboard just yet. Verify all of their wiring, primarily the power lines. So you just don't want 5 volts ever touching your ground directly. In other words, if they'd miswired the ground wire and put it into the red part, it may damage the Arduino, or it may damage the H-bridge. But once your batteries are in, so you do put your batteries in, you flip it back up, put it in just there, and you put this wire, making sure that the red side is going to the red side on the breadboard, like so. You can plug it into any of these pins here, but in that orientation. And once you plug this in, the robot will turn on if the Arduino has been programmed, and it will start moving. So tell your participants that this being plugged in or out is like an on-off switch. So if they plug it out, the robot will stop. I really hope this video has helped, and I hope you and your participants have a great time building the robot. Thank you.